So this session, there's this little thing called generative AI that I think a lot of people like talking about. And what we're going to talk about today is the additional context that you put with generative AI using something called retrieval augmented generation, or RAG. That uses vector databases in order to provide additional context into generative AI applications. My name is Riggs Goodman. I'm a principal partner solution architect at AWS.
I'm Isima Emmanuel. I'm a senior solutions architect here at AWS.
And so for today's presentation, we're going to spend just 20 minutes. We're not going to go that deep into secure RAG architectures. I'm going to give an overview of Bedrock for people who are not familiar with Bedrock, what knowledge bases are, and then dive into what security means with RAG architectures, because it is different compared to how you access databases, how you access other API calls to get that context to put it into your generative AI application. And then Emmanuel's going to go through and walk through exactly how do you go about building the right security architecture with data authorization in order to make sure that you're actually building them securely, so you're not going to have things like sensitive data disclosure and other things like that. So for people who are not familiar with Amazon Bedrock is a managed service in order for customers to use generative AI models. This can be from Anthropic, from Amazon, from Meta, but we host these generative AI models for customers so they can do all the front-end application stuff, and we take away a lot of the undifferentiated heavy lifting of using generative AI with your applications. So we give you options with models. We optimize for cost and latency and other things like that. We securely host these models for you, so you don't have to worry about GPUs and other things like that. Applying different safety controls with Bedrock guardrails, and being able to orchestrate things with agents. On top of everything that we do with Amazon Bedrock, we also focus on the security aspect and the compliance aspect of it. Security, what we're talking about, we don't take any of your data and train the models or give it to model providers. We use things like TLS and being able to monitor exactly what your users' prompts are, what the completions are, and other things like that. On the compliance side, we provide different capabilities so they can be compliant with different things like SOC 2 and other things like that. We make them eligible, but it's still up to you as a customer to build the right architecture so they can meet some of those compliance standards and other things. So that's Amazon Bedrock, but let's talk about a little bit of how do you add additional context to Amazon Bedrock. When I talk about adding additional context, what I mean by that is when a customer asks a question of a generative AI application, sometimes you want to include additional data as part of that context. So that could be system prompts or prompt engineering with generative AI. It can be retrieval augmented generation, or RAG, which is what we're going to talk about today, or it can also be things like fine-tuning models. Fine-tuning is basically having question-answer pairs where you're training the underlying model with additional data on top of what it has with just the massive amounts of data that the model is trained on. You can also do things like continuously pre-train the model and other things like that. For this presentation, talking about the security aspects, we're going to talk about RAG architectures and how you build secure RAG architectures with generative AI applications. So with RAG, the way that this works is when a user makes a query to Amazon Bedrock, one of the things that they can include inside that query is being able to say, I want to use this knowledge base. That is basically a vector database or a database that indexes different documents from S3 or other data locations in order to provide additional context when someone asks a question about HR policies, or what are the rules with certain things, or being able to look at documentation and other things and provide additional context back to Amazon Bedrock, and then it uses that additional context with the user query to make a call to that underlying large language model, whether that's Meta, Anthropic, Amazon, or others. That model will then respond back with whatever the output is in order to provide that additional context that you need. All right? So, this presentation, how do you provide the right security with RAG architectures? The example that I always like to use with RAG to explain how this is different compared to regular database applications is with RAG architectures, I compare it to a search engine. When you have an internal wiki site or an internal search engine and you send a query to that search engine, it's going to respond back with different data of like, these are different places where you can go to get understanding of exactly where to go for that data. But what do you do once you actually get those responses back? You click on that link, and depending if you are authorized to access that data or authorized to access that page, you're either going to get a 200 response or you're going to get a 400 response because it's checking your authorization on whether or not you get access to that data that is linked with that website and other things like that. With RAG, it's a little bit different. When you do the user query to Amazon Bedrock and it pulls additional context from that knowledge base, one of the things it doesn't do, it doesn't ask you as a user to actually go to that data source. It's indexing all the information in the knowledge base. It uses that context directly in order to pass it to the model and then come back with whatever the response is from the model. And so when you're thinking about security, you need to think about that overall of now you're not going to that underlying data source where you might have all permissions and other things, and you have to put the right security in place so you can make sure that only users that are authorized to certain data get access to the data in that underlying data source. And so when we talk about different security with RAG architectures, what customers are looking for is, one, being able to use that additional context from data sources and other things like that. They want to implement things that have auth-in or auth-z or authentication and authorization as part of it. They do want to use sensitive data that might not be available for public customers, but also sensitive data that you might have different user groups inside your organization. You might have a finance group compared to a sales group that they need to split the different data that only financial users are going to have access to some data while only salespeople are going to have access to the other. They use multi-tenant architectures. You want to be able to use data sources and have either one or multiple knowledge bases in order to build these multi-tenant architectures instead of having to build different applications for different users. And they want to protect against things like prompt injections. You don't want to build an architecture with one single prompt injection can get user access to sensitive data that they're not allowed to get access to. And so with that, let me turn it over to Emmanuel, and he will walk through 3 different ways to build RAG architecture securely so you're not you're providing the right authorization to that data.
Thank you. We are going to discuss 3 strategies when you're providing secure access to your RAG architectures. One is providing authorization at the application layer. The second use case is when you want to use separate knowledge bases in authorizing access. And the last use case is using metadata filtering. Let's walk through these one at a time. Let's start with what would happen if we want to provide secure access at the application layer. This is a use case where, like most of you have your identity provider that provides authentication. And so you do authentication at your identity provider, and then you move to your application. That is where you do authorization. And based off the authorization that you perform there, you now provide fine-grained access to Amazon Bedrock. And then from Amazon Bedrock, you can now go to your knowledge base and then to your data source, retrieve whatever contextual data you need, augment it with the initial prompt, and then send it to your model, and then the user gets the response. Again, we are performing authentication at your identity provider, and we are performing authorization at your application. A second use case we see out there that we recommend our customers to adopt is when you have different business units. Let's say you have a billing and a finance team, or a sales and a finance team. You could have those different group of users in your identity provider. You have group A users and group B users. You could use separate knowledge bases. So for group A users, they go to your knowledge base B. So let's say group A will go to knowledge base A, and group B will go to knowledge base B, and then from there get access to data. To explain this a bit more, let's look at this. We'll have your identity provider performing authentication. The user comes in there, it goes to the application to provide authorization. The authorization here is going to give them access to the Bedrock knowledge base. So for a user that is coming from group A, the application layer is going to authorize them to Bedrock knowledge base A. A user that is in group B, your application is going to provide them access to Bedrock knowledge base B. And then from there, they will now have access to your data, be able to pull the right data, combine it with your initial prompt, send it to your model, and then you get a response. The third use case that we see out there is when customers want to provide fine-grained access. And this is when you use a feature called metadata filtering. Basically, with metadata filtering,
you are going to line up those attributes you are interested in and then perform pattern matching. Now, what happens is you're going to include in your knowledge base, let's say you have this data being stored in S3, you are going to include a metadata.json file. Within that metadata.json file, you are going to mention those attributes that you're interested in. Let's say score number. So you are interested in people, in data that only matches a particular number, maybe beyond, maybe 10 if that's the number you're interested, or 20, whatever the number is. Now you're going to perform metadata filtering, which is just pattern matching, and then you're going to indicate what is the filter you're interested in. Now matching that to whatever attributes you are interested, you were looking at initially. Just to make this very, very clear, you have a user come into your identity provider, they perform authentication, you perform authorization there. Then once the user, in the query that the user makes, we are going to perform a metadata filter, which as I mentioned is just a pattern match. And then that pattern match will look at your data that is stored on your data source, which is already, you will already create a catalog of that data using the metadata.json file. If we look at the score number earlier, it means that within your data source, we already matched certain data that matches a particular number and a particular score, right? The score, that's a key value pair. So we're going to only match those data that matches that, and then we're going to send all those data to your prompt, and then it goes to your model, and then you get a response. What this provides is that fine-grained access to only the data that the user particularly needs. Now, so these are the 3 patterns we see out there that we recommend to our customers. Just to summarize, first of all, you want to use an identity provider to provide authentication and then perform authorization at the application layer. The second recommendation we mentioned is use separate knowledge bases. If you have the right data strategy in place, you know your data, you want to use separate knowledge bases to perform data separation. The third item is you want to use right tagging. Tagging will really be important when you start growing, right? You have your knowledge base giving you access to your data. As you bring in more data, you apply the same tags. You don't need to, you just need to use the same knowledge base to apply, to access those data. And then the last item for providing fine-grained access, you can use metadata filtering. We have these resources that will guide you. This is a blog, and then security for GenAI documentation. So that's all we have. Thank you.
Thank you.